All right. Good afternoon, everybody. Great to see so many of you here. Welcome. We're going to talk to you this afternoon, taking a look under the covers of Spring Boot and showing you what kind of magic is lying under there. My name's Andy Wilkinson. I work for Pivotal, where I primarily spend time working on the Spring Boot project. I'm also the lead of the Spring I/O platform and Spring REST docs projects.
Right. Hello, everyone. I'm Stéphane. I'm also working on the Spring Boot project, Spring Framework, and start.spring.io if you happen to use that.
And talking about people using start.spring.io, you now know a little bit about us, but let's try and find out a bit about you. So can we have a show of hands, please? How many of you have never used Spring Boot before? A handful. Not too many. No. Okay. And those of you who are using Spring Boot, how many of you have got boot apps running in production? Wow, cool.
That's a lot.
Good to see.
Yep.
And what versions of Boot are you using? Have any of you, have you got Boot 1.4? Are you up and using 1.4? And 1.3? Still more on 1.3 than 1.4. Okay, yeah. Well, hopefully we can drag some of you on, up to 1.4 when you see some of the new goodies that are in there.
Okay, so this session will be mostly live coding. We'll use some slides just to assist with the explanations, but we will mostly show you in practice how Spring Boot is working in the inside. Those projects, so we'll work on two projects. Those two projects are already available on GitHub, and we'll give you the links to the repositories at the end. Okay, so since this is about understanding how Spring Boot is working, we are not going to build any kind of fancy app. We are really going to focus on the infrastructure part and what Spring Boot can do for you. So we have an app. We have an app that does nothing for the moment. So if I start it there, it will just print startup information and exit right away. So it's not a web app at all. It's just like a command line thing. And we also have a service that's very complex, as you can see, with one implementation that takes a prefix and a suffix to the message and just output something in the console, right? If we look at our application, it has a dependency to that service, and now we are going to add some stuff to it. So what can we add to it? We can use the service in a command line runner. So let's do that. So I'm going to create a new file, hello command line runner, and I'm going to implement that command line runner.
And command line runner is just an interface provided by Spring Boot, and any beans that implement the command line runner interface will be called as part of your application starting up. And as you can see here, the run method is given the arguments, the command line arguments that you invoke your application with.
And in that service, so on startup, I'm just going to say, I'm just going to invoke that with well, whatever, right? Nothing fancy. I'm also going to tag that class as a component. We'll see soon what that means. So it's going to be picked up by component scanning. And if I start this application, it will obviously fail because there is actually no hello service bean in the context. You've seen this nice error message that Spring Boot is giving to tell you that something is wrong in your config. We'll see also during this presentation or how that works. And a Spring Boot application has triggered the processing of that file, and a Spring Boot application is also a configuration file. So I can create this hello service as a bean and just return whatever implementation I want. And if I do that, simple, right? Just to put things in perspective, it will work and we'll have our message printed out there.
All right, thank you, Stéphane. So here you can see the app, the very simple app that Stéphane's just introduced us to. And we'd like to now use that app to kind of start digging into what exactly is happening when it's started up, what Spring Boot is doing for you, what's going on under the covers. So the thing that makes that app a Spring Boot app is the Spring Boot application annotation that typically goes on the same class where your main method is. And this annotation does 3 things for you. So it's actually meta-annotated with 3 other annotations. It's a Spring Boot configuration. Most of you already familiar with Spring Framework. Spring Boot configuration is just a specialization of Spring Framework's configuration annotation. There's component scan. This is just Spring Framework's standard component scan annotation. And then there's enable auto configuration, and that's the annotation that switches on Spring Boot's intelligent configuration based on your class path or properties that you've configured, things like that. So to start with, and just to make sure that we've got everyone kind of on the same page and has a really good understanding, we're now going to dig into component scan and what that does when your application starts up. So you have your component scan annotation on a particular class, and that essentially associates the scanning with a particular package. So here we saw the class that was annotated with Spring Boot application was in the com example hello package. So that means any components, like Stéphane showed you, he added the component annotation to the command line runner implementation. That means that that component will be picked up by component scanning when you start your application because it's in the com.example.hello package. Similarly, if you nest packages beneath that, then their contents will also be picked up. Any components that are in a sub-package of com.example.hello, so com.example.hello.alpha or hello.bravo, nested packages beneath the hello package will be found by component scanning. What won't be found is anything that's a sibling, if you like, that isn't nested beneath com.example.hello. So here, com.example.charlie, that's not going to be found. And this can be a reasonably common gotcha when you're writing a Spring Boot application. If you add some new code in a new package and you're expecting the contents of it, the components in there to be found and they're not, it's worth double checking what package it's in and where your package is, where you're declaring your component scan annotation, and just making sure they're in the same package or it's in a sub-package of it. If it's not, you can just refactor your code, move it underneath, so it's now com.example.hello.charlie, and the components will then be found. All right, so we've got our package, and in that package we find components. But there's other things other than just component. There are various specializations of components. So the repository annotation, these kind of give a bit more information about the type of component that it is. So it could be a repository or it could be a Spring MVC controller, could be a REST controller, so one that's going to, any values returned from its method are sent back as the response body. Could be a service or it could be a configuration class, which is a component itself. So, hopefully that all gives you a bit of an understanding of how component scanning works, but now let's go back to the app and see those 2 in action.
Right, so no magic, right? So we can actually remove that thing completely and replace that by the 2 annotations that we are, let's say, interested in, since we don't have any kind of auto-configuration use in this application. And
it's worth it just at this point, I think, pointing out you don't actually have to use component scanning in a Spring Boot app. It's what we consider typical, which is why it's rolled up into the Spring Boot application annotation. But if you're not a fan of component scanning and you prefer to declare everything in your configuration classes with bean methods, then you can do that. You don't have to rely on it if you don't want to.
You can use also import to specify the classes that you need to pick up rather than using component scanning. So if we move that class, again, if we move that class to a nested package, for instance, so let me create quickly a nested package called app, and I'm going to move that thing to that nested package. And if I restart again, then right, the app is still working, but we don't have the message anymore. So this is really why we strongly recommend you to put your application. Well, first of all, have a dedicated package for your application, for each application that you are working on. That's one. meaning dedicated is that it's private to that application. And 2, put your Spring Boot application at the root of that package, like we are doing here, basically. Let me move that back. Right.
Okay, so let's. This is the code that Stéphane showed earlier. So we've got the Spring Boot application and the command line runner. And there's a couple of bits there that are interesting. So there's the component and there's the bean. And these are all the other things. So these are all the things that are going to be found when your application starts up. So we'll look for configuration classes, and any bean methods declared on them will create components. And then there's also the component annotation and then the specialization of it as well. And all of those things will create beans for your application and include them in the application context. So we have user configuration, for example, using component scan, or using configuration classes with bean methods, or using the import annotation to directly import a configuration class, or if you're feeling masochistic, you can use import resource and import some XML. Or you might have an old application that you're trying to migrate to Spring Boot, and that can be a nice way. You don't have to, as part of migrating to Spring Boot, you don't have to get rid of any old XML configuration that you may have. You can still use it using the import resource to pull it in, so you can kind of do a more gradual migration rather than have to throw it all away and rewrite it all at the same time. So we've got the user configuration that's provided a bunch of beans. And then we have auto configuration. So you switch that on using the enable auto configuration annotation, which you will get if you use the Spring Boot application annotation. Or you can split them up, as Stéphane showed. And that will add a number of beans to your application as well. So there's 2 separate phases that happen here. And it's important for reasons that we'll explain later on that those phases are distinct. Your user configuration gets a chance to contribute beans to the application. And all of those are kind of put in place, and then auto configuration runs, and it can add beans to the application context. But that happens after all of your user configuration has had a go. So let's look at enable auto configuration now and what that does.
Yep. So you might guess that at this point, we are going to improve our project so that we don't have to register the hello service bean, and auto configuration takes care of that for us. So we are going to create a simple auto config, and you'll see we'll improve it later on. So for that, I'm going to add an extra module here called hello starter. And hello starter contains a single class that's empty for now, because the whole purpose of the thing is that we show you how to do it. And there's a test. And the test showcase how you can actually test auto configuration. It's very important that you make sure that if you build an auto configuration that it behaves as expected. So I have here a default service is auto configure test. So I'm going to write the code that's supposed to test the behavior I'm going to add. Then I'm going to explain what that does in practice. So I'm going to load a context.
That's just programmatically creating a Spring application context using passing in a configuration class. They use this as the source of any beans.
Yeah, I should probably first add the dependencies that I need. So there is 2 ways you can build a starter, really. One way is you have a module with the code, with the auto configuration code, and you have a separate module that represents the starter. So the starter is the thing that you ultimately use in your application to bring the dependencies. The interest of making that separate is you may want to have the code at all time and just bring additional dependencies that will trigger the use of the auto configuration. That's what we do in Spring Boot. So when you have a basic Spring Boot app, the auto configuration code is present, and it will kick in if dependency are added, or if you set properties or whatever the auto configuration is looking at. Another way for smaller use cases is to actually merge those in 2. So have the auto configuration code and the list of dependencies that you need in the same artifact. And this is what we are going to do here. So it's very simple. So to get started writing an auto configuration, I can just use the starter, the basic starter, which will bring the core bits of Spring Boot. And obviously, I need to have a reference to my service. And if you have a reference to the starter, that's going to bring everything you need to get started. So let me inject that thing. Service is probably better for a name. I'm going to call it with whatever world and assert that it contains the string that we want, right?
And this is just using, you can use this in your own apps as well if you like, the output capture thing that you can see near the top of the code is a JUnit rule. So when the tests run, it grabs hold of system out and system error and captures all of their output, so you can assert that particular output was generated while the code was running.
So it doesn't work because the service hasn't been defined, because we haven't coded anything. And so if we go back to load, if you are writing tests that uses the Spring framework or Spring in general, you use to this JUnit rule that you can use that will start the context for you, the run with extension of JUnit, sorry. And that will start the context. It will make sure that the beans are created and you can inject those in your own code. So the test itself becomes a bean. You can't really use that with auto configuration because you need to have full control on the way the context is going to be started, and you need to tune that. So for instance, you need to start the context with no user configuration, then you need to start the context with there is some kind of user config that you need to detect and not override, for instance, or you want to pass some properties to make sure that the auto configuration will react to that. So all your tests are basically starting a context in a different way. Starting a context is really not complicated at all. You just register. In this case, I'm just going to register a configuration that mimics what the user will actually do. In this case, it's doing nothing, and we will fill in that later when we'll improve our auto configuration.
And you can see loads more examples of that approach to testing in Spring Boot's own tests. We do it all over the place in our tests for Spring Boot's own auto configuration classes. So if you're looking for inspiration, then that's well worth a look.
So what is an auto configuration really? Well, it's a configuration class. There's really nothing specific about it. And then you contribute a bunch of beans. So let's do that. And that's about it. That's an auto configuration class. Very basic still, but we'll improve it. What's specific about that configuration class is that you're not going to scan it. You're not going to refer it with import statement or whatever. You're going to register it in a specific file that Spring Boot will look on your class path on starting. So that file is, well, I probably need to create a resource directory in there. So that file is contained within a directory called metainf. You probably all know about that. That's a file a directory I meant to create, sorry. And the file is named Spring Factories. And
you may have seen this before. This is the actual plugin mechanism that Spring Boot uses as a standard part of Spring Framework. So you may already have used this in your Spring applications, even if you're not using Spring Boot.
So the key is, you'll see that in other examples today, you need to register your auto configuration with a specific key, and the key for auto configuration is the fully qualified name of the enable auto configuration annotation. So I'm just going to register my hello auto configuration and run my test again. And
that's just a comma separated list. So if you have more than one auto configuration that you want to register in your own starter module, you list the key once, and then you just have a comma separated list of all the configuration classes that you want enable auto configuration to switch on.
So the test is passing now. So what I can do is can basically change service by starter and run the thing again. I'm in the app. Then we can see that the message has changed, and that's probably really bad because we have an opinion, right? in this application still. We have an opinion about this app. We want the hello service to be created in a certain way. And we can see that our auto configuration doesn't respect that. So we'll go back on that in a minute to add some conditions to it.
All right, so that was kind of a basic auto configuration. Excuse me, just to reiterate, so the key thing that drives the enabling of auto configuration and lets you plug in is the metainf spring.factories file. So you have the key, which is the fully qualified name of the enable auto configuration annotation, and then the value is a comma-separated list of the fully qualified name of the configuration classes that you want to be switched on by enable auto configuration. And then that just directly references what is or can be just a completely plain standard Spring Framework configuration class. There's nothing fancy going on in the actual configuration code to make something auto configuration. It's just being switched on via that entry in Spring.Factories. But as we've seen, that was kind of useful in that we had a bean provided for us by default, but it wasn't as useful as it could be. For example, our app was trying to express an opinion about the hello service, and the auto configuration was just trampling all over that opinion and replacing the app's bean with the auto configured one. So we're now going to take a look at what you can do to make your auto configuration a bit better by making it conditional and also using properties to make it configurable.
Right. So let's do that. So the first thing that we want to do is probably write a test that materializes that behavior. So let's write default service backs off. And rather than loading an empty config, let's load a user configuration.
And this kind of ties into the point Stéphane was making before about not using Spring's standard, the Spring runner, Spring JUnit 4 runner in your test for your auto configuration, because to test all these different scenarios, for example, that it's backing off, you need to have really kind of tight control over which configuration classes are being used and which order they're being run, which is why you have to have that kind of 4 or 5 lines of boilerplate just to fire up your application context with the appropriate configuration classes registered.
So let's see what we can do. There we can pretend, we can fake some kind of user configuration and see how the service is going to react to it. So, and let's change the prefix maybe, and the suffix. So mine a double star. So if I'm loading this, I expect the auto configuration to notice it and just not do anything. We still have one hello service bean only and not 2. And the output is the one that I've created myself. So as you can see, with a few lines of code, you can test your auto configuration quite easily once you have the infrastructure around. So this is failing because we still have our auto configuration beans that's configured. So to fix that, it's really easy. You need to add a condition on the bean. On the bean definition, in this case, conditional on missing bean. And conditional on missing bean, when it's specified on a method like this, it's going to automatically take the return type as the type to look for. You could also specify the types here as an argument to the annotation. But there's a nice shortcut if you put it on a method. It's usually you'll put that on a bean method, so we take the shortcut of inferring the default return type as the default.
So just to be completely clear, this is saying here that this bean will only be created if there's no other bean in the application context already that is of type hello service.
The other thing that we can do, even though it's useless, but let's show it anyway, you could also react on the fact that hello service is actually available. It is useless in our case because the auto configuration code and the starter are in the same project. So whenever you rely on the starter, you'll get hello service transitively because it's defined in the POM file. But if you choose a different approach where the auto configuration code can be separate, you need to guard with the presence of the library itself. And to do that, you can use a conditional on class and just say, if hello service isn't there, don't even try to load the class at all. So you may wonder how that works, because that may be evaluated while hello service isn't actually present. So we don't know the class. We use ISM to read the bytecode of the class, read the metadata, and figure out that there are such conditions on them. And if they fail, the condition won't be, the class itself won't be loaded. Right, so we can use that in our app now, and hopefully if we do that, we should be able to get our message again. Right. So now I'm going to actually use the auto configuration and remove the bean, and what you experience with Spring Boot should happen. This is what's happening now. So there is no bean present, so Spring Boot is, via the auto configuration that we've wrote, is going to configure one for you. But there's a problem, because in this application, I want the prefix to be howdy and not hello. And, well, if I want to change it, I could write this. But this is really what I don't want to do, because even though in this case the service is very easy to instantiate and probably the auto configuration a bit useless, in real world scenario, the configuration is much more complex and has many customization points and logic, etc. So you can't really just say, okay, if something doesn't match, I'm just going to configure everything myself. So let's see what we can do to actually still get back the howdy prefix. And let's create a few, let's change our test here, and let's pass some properties. So let's say, I want to say howdy. So hello prefix doesn't exist. We are going to take care of that. And write this, okay? So that should fail, because there's no reason hello.prefix is managed. So now let's see what we can do to customize the auto configuration. So to customize the auto configuration, there is a neat thing in Spring Boot called configuration properties. So configuration properties are really simple POJO. There is really nothing specific about them. And if you add this configuration properties tag, you're basically asking Spring Boot to bind the environment starting with a certain key to your POJO instance. So in this case, I'm defining a hello.prefix and a hello.suffix because I have a set prefix and a set suffix method there to the environment. So if you have, if in your environment you have a key that's named hello.prefix or hello.suffix, this bean will be the setters of that bean will be called. Configuration properties isn't really anything fancy, so it's not a component. We made that on purpose because we wanted configuration properties to be very simple and only relates to the environment. So we don't want you to start injecting stuff into that, add complex logic, but really focus on the environment, which is something that's very, very basic in your application. So to trigger that, I can trigger the processing of this. And once I've done it, I can actually inject it. So anything that we are showing you here are not related to auto configuration. If you want to do that in regular configuration class, you can do so as well. And I'm going to change this to use the values, so the prefix and the suffix typically. And if I run the test again, it passes now. So which means I can go back in my app, and I can type hello.prefix with this, run my app again, and I'm back on track. I'm back to what? Oh, that's something you were not supposed to see now, sorry. Hello, hello. Okay. Revealing a demo I'm not supposed to enable now. That's the demo effect, I guess. Okay, so we're back on track. Okay, so basic autoconfig, adding conditions to add more logic to your auto configuration when it kicks in, when it has to back off. Properties is a really nice way to customize the auto configuration with properties, but we still have one problem. And that problem is that the IDE is complaining that this property is not known. If you're used to Spring Boot, so you're used to this nice auto-completion feature where you can basically list the keys that are available in the system. You can search for keys. You can see the documentation, the default value, etc., etc.
And there's support for that in IntelliJ Ultimate.
STS and
there's
NetBeans.
a STS, and then there's also a NetBeans plugin as well. So hopefully, whichever IDE you're using, you can take advantage of that.
So what does it take now that we have all that to register those keys in the IDE? If we go back to the properties, IntelliJ IDE actually gives us a hint that some dependency isn't found. And that dependency, let me add that right now. It's called Spring Boot Configuration Processor. It's an annotation processor, so it's a standard hook point on in the compiler. If you don't know that, if you had such library in your project, the compiler detects it pretty much the same way as Spring Factories does. There's a file you need to put at a certain place with the fully qualified name of your annotation processor, and the compiler will detect that. And it will give you a chance to inspect the model of the classes while they are being compiled, and give you a chance to generate resources or generate extra files, extra source code, etc., etc., or modify the actual object being compiled. So if I add this, and I go back to my little thing there, I have the auto-completion now that's working. So this is really the only thing that you need to do. And what's happening behind the scene, so the annotation processor is basically looking for all the classes that are annotated with that annotation. So the trigger of the annotation processing is the presence of configuration properties. And it generates a metadata file automatically, looking at the source code of the file, and it generates a metadata file, and the IDE supports actually reading that file to give you the content assistance.
Do you want to show, excuse me, do you want to show how to document a property?
Yeah, good point. So there is no documentation right now. The way it works is you put javadoc on the field. This might seem a surprising decision, but it was very carefully. It was a very careful decision. So the rationale behind it is we could have detected the javadoc on the getter or the setter, for instance, but we didn't want you to force structuring your documentation in a certain way. For instance, if you want the description of the of a property, you don't want return or set inside the content of the description. So you'll have to change it to match what the metadata is expecting. By putting that on the field, then you have the ability to craft a very specific description that's only going to be used by the metadata and still have the javadoc on your getter setter any way you want. So let's write something, right? And the nice thing about that is you can also put some additional information right in there so that your users can have that information without actually having to go in your documentation. So for instance, in this case, the prefix, we add a space between the prefix and the message. So we could say so. Again, it's very sunny day, but you can relate to that for any use case you have. Whatever, right? And if I recompile, I only need to recompile to trigger the annotation processor again, and I can have access to the javadoc now. And if I remove this, you can't see it because the screen is a bit we've increased the size so that you can see. But if you are at regular scale, the description is much more visible.
One other thing before we go back to the slides, do you want to show the auto configuration report?
Yes.
So
Good
when the Spring Boot app starts up and it looks at all the auto configuration classes and it looks at the conditions on them to decide what's happening, to let you get some insight into that, if you start your application in debug mode, so with --debug, for example, as a command line argument, Spring Boot will spit out this report which tells you all about all of the conditions, so that you can see there, for example, the ones on the auto configuration that Stéphane's just written. And if you're using Spring Boot's actuator, you can also get at this via the auto-config endpoint. You don't have to, if say you forgot to start your app with --debug, if you have the actuator running, then you can get at it via that as well, rather than having to restart your app just to take a look at the report.
So you get the positive matches, so you know why something has been done for you, but you also get the negative matches, which basically explain you why Spring Boot couldn't do something. So let's say you expected to use, I don't know, RabbitMQ in this application, and you get an exception because some RabbitMQ specific bean you're relying on are not present. Then you could look why isn't it the case in this application? And actually Spring Boot is telling you, well, those classes are not present. So since those classes were not present, I didn't do anything. If you have such a case, probably the condition will be much more narrowed, some property missing or something like that.
All right, thank you, Stéphane. So we've seen how to write an auto configuration and seen how to make it a bit better by adding conditions to it. And we'd now like just to spend a bit of time diving quite deep into the conditions, all the different conditions that are available, and exactly how they work. It's an important, if you're going to write your own auto configurations, it's kind of understanding exactly how conditions work and all the different conditions that are available to you should hopefully make your life quite a bit easier. So here we can see two conditions were used. We had conditional on class for the hello service and conditional on missing bean. So coming along with conditional on missing bean, there's also conditional on bean. So that's a way of switching something on if a bean exists in the context rather than a bean being missing from the context. We make extensive use of this in Spring Boot. For example, we only auto-configure Hibernate if there's a data source bean already available in the application context. If there's no data source, then that's a pretty good signal that you don't really care about any data access type stuff, so we'd switch off the auto-configuration of Hibernate. Going with conditional on class, there's also conditional on missing class. This isn't probably used quite as often, but conditional on missing class can be a nice way of providing a basic implementation of something. So say, for example, you had an HTTP client and you were going to provide kind of a rich, fully featured one if, say, OK HTTP was on the class path. But if it wasn't there, you didn't want the app to break. You just wanted to provide a more basic implementation of your HTTP client. You could use conditional on missing class to say, well, if OK HTTP isn't there, then I'm just going to use standard JDK classes, for example, to implement the client. Conditional on property. So we saw Stéphane adding entries into application.properties. You can make something conditional on a property having been set and having a particular value. So we use that in a few places where you can enable or disable stuff via properties. So we might have a conditional on property that says com.foo.bar needs to, a dot enabled needs to be true. And if it isn't, then that switches that piece of functionality off. We also have a couple of conditions for whether or not your application is a web app. Hopefully fairly self-explanatory, and when those might be useful. For example, we use those in our auto configuration for
templates.
Yeah, templating stuff. So a lot of the templating libraries have kind of two different modes that they can run in. One for kind of a web MVC kind of rendering, or one for a more back-end rendering mode. For example, sending emails. They're quite often used for rendering a template for email sending. So we use those to auto-configure different things depending on whether it's a web app or not. Conditional on resource lets you switch stuff on and off depending on whether a particular resource is available on the class path.
For instance, we use that in the caching infra a lot. Most caching libraries, they have like a bootstrap. If a bootstrap file is present, they're going to pick that up for you. For instance, ehcache, if you put a ehcache.xml at the root of the class path, you still need to configure everything yourself. But if you don't provide a path to a configuration file, it's going to take that by default. So the ehcache cache configuration checks if there is an ehcache.xml at the root of the class path, and if so, configures it for you.
And then we have conditional on single candidate, which is very similar to conditional on bean, but what it's saying is, so conditional on bean is basically if there's one or more of this type of bean, then switch it on. Conditional on single candidate is saying there has to be exactly one. And that can either just be because there's a single bean, or there are multiple beans, but one of them is annotated with Spring Framework's primary annotation, which indicates that it takes precedence over any other beans of the same type. We have conditional on Java, so you can switch stuff on and off depending on which version of Java you're running on. So Spring Boot 1.4 supports Java 6 through 8. For example, in Spring Boot's actuator, we have some code in the metrics support which makes use of some new types in Java util concurrent that appeared in Java 8, which lets us do kind of high performance in-memory buffering of metrics. That only gets switched on if you're running on a Java 8 VM. If you're on Java 7 or Java 6, you still get the buffering, but it just doesn't perform quite as well. Conditional on JNDI, useful if you're packaging your boot app as a WAR file and deploying it to an app server. Actually, that's an interesting question to ask. How many of you are deploying boot apps to a traditional app server or servlet container? Not many. I assume the rest of you are running embedded containers. Cool. And last, and in some ways least, conditional on expression. We don't use this one anywhere in boot itself. This lets you activate stuff based on a spell expression. So you can basically go crazy with this one and do pretty much
Don't do that.
whatever you like. I would say use it with caution. It's a sharp tool, it may cut you. Quite often one of the other conditions will do the job, or you may actually be better served by writing your own custom condition, which we'll talk about later. All right, so let's now talk about the process of the conditions and how they work and how they're processed and what happens. So we talked earlier about enable auto configuration. Underneath that, it looks at the spring.factories file, and that pulls in various configuration classes. So here we have a couple of spring.factories files. Beneath that, we have some configuration classes. So this is just exactly what Stéphane showed you earlier. These are just standard configuration classes that are referenced via spring.factories, so they're switched on by auto configuration being enabled. So we've got 4 here, all configuration classes. The most simple case is just the configuration class with no conditions on it, and that is just switched on. It's kind of implicitly switched on. There's no conditions, so if enable auto configuration is switched on, then that configuration class will be considered for providing and contributing beans to the application context.
You may have conditions on bean definitions in that class, though. And if the conditions do not match, as we will see, then we will still check for those conditions. But it means that class will be processed, will always be processed.
Yeah, there's basically kind of 2 phases to looking at. So first of all, we look at all of the configuration classes, and those that have conditions that match, we then look at the bean methods on them. So here we're just talking about class level conditions and whether or not these classes are included in the second phase of actually looking at their bean methods. So slightly more complicated, we've got Bravo auto configuration here with a condition on it. So that condition is evaluated, and if it doesn't match, then the configuration class doesn't match, and that's ignored from that point onwards. Slightly more complicated again, if we have 2 conditions on a configuration class, as you'd hopefully expect, both of the conditions are evaluated, and they both have to match for the configuration class itself to match as well. And lastly, if you have 2 conditions, and we evaluate the first one, and it doesn't match, we don't bother looking at the second one. So it short circuits. And that can be useful because some conditions are more expensive to evaluate than others. So if you're writing your own condition, they can be ordered. And if you know that your condition is very quick to evaluate, you might want to give it high precedence so that any slower to evaluate conditions aren't unnecessarily checked when your quick one would have switched something off anyway. So one condition didn't match, the whole thing doesn't match. And as I said, the second or any subsequent conditions after one hasn't matched are just ignored. All right, so in that case, there were 2 configuration classes that had matching that were matched. One that didn't have any conditions on it at all, and one that had a couple, and both of them matched. So let's focus in on one of those now. And then, as we kind of started to describe earlier, we now look down at the bean methods on the configuration class. So for every configuration class that has passed the first kind of pass, the first sweep through of conditional evaluation, then is input into the second sweep through, where we then look at all of the bean methods on the configuration class. And exactly the same thing happens again. We look at the bean method, we see a condition on it, we evaluate the condition, and if the condition matches, then that bean is contributed to the application context. So the bean definition is registered with the bean factory. So these are all the conditions that we looked at before. And 3 of them are a bit different to the others because they rely on the state of the application context. All the others are kind of environmental and look at things that don't really change, like what's on the class path, what's available in JNDI, whether or not you're running a web application. Those are things that are unlikely to change or won't change during the course of your application starting up. Whereas these 3 bean-related ones, they can change depending on whether or not something else has contributed a bean to the context. So, for example, if conditional on missing bean was evaluated too early, then you might not find a bean and go, oh, yeah, that bean is missing. I'm going to contribute. This condition is going to pass, and this configuration class is going to be switched on, or the bean method is going to be switched on. And then something afterwards comes along and runs and provides a bean, and the auto-configuration one will already be there, and you'll end up with 2 beans, or one will override the other, or you'll get some unexpected behavior. And this is why it's very important that auto-configuration runs after user configuration. So it gives your user configuration a chance to contribute beans to the application context. And then the auto-configuration itself can run, safe in the knowledge that any overriding beans that should make your auto-configuration back off will be there, so that when the conditions are evaluated, it's got kind of the right view of the world, rather than looking at things prematurely. The other thing I mentioned was when there are multiple conditions on a particular class or particular method, is that they're evaluated in order. And this is the order that they're considered, from highest precedence at the top to lowest precedence at the bottom. So conditional on class and conditional on missing class, they're really quick to evaluate. It's just, can we load this class? Is it on the class path? Right the way down to the 3 I've just talked about, conditional on single candidate, conditional on bean, and conditional on missing bean. Those 3 are potentially quite slow to evaluate because we have to interrogate the application context and find out if there's a bean of a particular type. And that might involve looking at factory beans and seeing what type of beans they might produce. And so it's a fairly involved process to figure out. Relatively, in real terms, none of them are that costly to evaluate. But relatively speaking, the bean-related conditions are slower than, for example, the class ones. So the ordering, if you're using a condition extensively and it is very slow to evaluate, you want to make sure that you order it with quite low precedence, so that other things, there's a chance for it to be switched off by another quicker to evaluate condition that could go before it. So that was the conditions that are all available out of the box. Now let's see what it takes to write your own.
Okay, so let's have a funny use case. Let's pretend that it's actually valid. First, I'm going to write 2 tests that are actually exercising that new condition, and they will fail. So what we want to do is, if the prefix is not specified, we want to stop contributing the hello service, so make that a bit mandatory. So to make that work, I obviously need to change this. So stop providing a default value. And 2, we want to add an extra condition just to show you what kind of things you can do. And if the prefix doesn't start with an uppercase letter, we want to back off as well. So these are the two conditions that we want to add to our auto configuration. So let's write that quickly. So I'm adding an empty configuration so that I give a chance to the auto configuration to kick in, and I'm not passing any customization, so the hello prefix won't be set. So in that case, I want to inspect the context for being of a certain type. In this case, that's the hello service, obviously. Service. And I want to make sure that's actually empty. And I have import. Come on, IntelliJ, you can do this. Really?
Do you have the test starter on the class path?
Yeah, I do. Okay. Why? Okay. And the second one is same thing again, and just to show you how easy you can test that, because that's really something very important about auto configuration. So now I'm passing a value that's invalid because it doesn't start with an uppercase there, right? It's not this, it's this. Okay, so let's run those tests. You may wonder also how you can easily pass properties to the environment. This is happening in the load method. Right here, you can pass a pair of key value. There is a test utility that you'll get with the starter, with the Spring Boot starter test, which allows you to do this. And that allows you to contribute keys to the environment before the application context is refreshed, which means trying to start the context, if you will. So we need to build our own custom condition now. So let's do that. I have something like unvalid, yes. Unvalid hello prefix condition. So what does it take? You need to implement condition. So by the way, the condition framework is not in Spring Boot at all. This is a core Spring Framework feature. It started with the profile annotation that allows you to switch things on and off according to whether or not a specific profile has been activated in your app. And that profile annotation has been changed, so we open a bit the scope, and condition was added to the framework. So if you look at Spring Boot condition, it's really implementing the Spring Framework's condition. The reason why you want to use this one is this gives you a way to contribute things to the auto configuration report. So we've seen that if you start using those standard annotations, automatically when you start the app and you trigger the autoconfig report, you'll get those nice messages generated for you. In this case, we are going to create our own condition, so we need to somehow tell the user what happened. So the second thing that we need to do is we need to play with the environment, and we can't just say, tell me if hello.prefix is present, because as you know, you can also configure your keys with different schemes. For instance, you can pass the following as a system property, and it will override the value, or an environment variable, or whatever. If it was a two words property, you could write it like this, or you could write it like this, or you could write it like this. That's the relaxed binding in Spring Boot. So you can't just hardcode hello.prefix. It won't work. Hopefully, there is a service that you can use for that called Relaxed Property Resolver. You just pass it the environment and the prefix of your key. Then you can just ask, give me the value for prefix. And the thing that you pass will also make sure to test the various cases that are supported. So I'm starting by writing a condition message builder for my condition. So this is the name of my condition. So when you look in the auto configuration report, you'll see that this name will be present. I'm checking if I have a key for prefix. If I don't, I simply use the no match condition outcome. So I'm basically saying that condition didn't match. And I provide some information about the reason why. And in this case, that's because I didn't find a property called hello.prefix. I only have one item, but I could have also written this. It's really nice. I love this. This is new in the latest 1.4. And whether or not you provide one or more items, it will automatically use the right cardinality. if there is a value, I can get it and just check if it's uppercase, if the first character is uppercase or not. And again, if it's the case, then I match, the condition will match with some information that tells you why it matches. And if it doesn't, then again, I'm using a because condition where I give the explanation as to why it didn't work. So how can you actually use that condition now? Well, it's very easy. Since it's a standard Spring Framework feature, you can go on the condition here and type conditional, which is the way to trigger a condition and pass the class of your condition. So if I start again, my test will pass, which means that the condition has been applied. Next up is you may want to hide.
What can we? How about we take a look at the auto config report,
yes,
and we can see that
good point,
lovely, carefully crafted message.
Oh yeah. So first of all, it still works right, the world. So let's remove this, which hopefully should make the application crash. It does. So it's telling me now that the application has failed to start, and it also gives me one possible candidate that could have contributed that bin. We'll talk about failure analyzer in the second part of this talk. If we go back to our condition, one condition matched, the hello service class was found, and this one didn't match, and then you can find valid hello prefix didn't find property. If you specify it with a lowercase, just to show you what kind of message it generates. So valid hello prefix rejected the prefix, and then you can give the value, so you have actually what the value was processed, as it doesn't start with an uppercase character. Right. So this one is a bit unusual to what we've seen so far. Usually you have an annotation that just allows you to declare the condition. So what does it take to actually do the same? It's really about creating the annotation and putting the condition on it. So let's do that. Let's create an annotation conditional on valid hello prefix, whatever you need for your use case, right? Then you need to put the retention thing, which I always forget. So I'm just going to copy paste that. Don't tell me you don't do that as well. I'm sure you do. And to make a custom condition, well, the only thing you have to do really is just to flag the condition, and that's it. And then you can use in your auto configuration, you can use the condition rather than conditional with the conditional class. The advantage of doing so is that you can also hide the implementation now. So only the annotation is a public API.
And you can, another thing you can see here, the annotated type metadata that's passed to the condition. So in this particular case, the annotation was very simple. It's just an annotation that doesn't have any attributes. But you can have, as you've seen, as we've shown you, you can have a conditional annotation with attributes on it. So you can have conditional on class and then the name of a class, for example. In your condition implementation, the annotation type metadata that's passed in, that's the stuff that Stéphane was talking about. We use ASM to look at the code. So it's metadata about the annotations that's been loaded via ASM. So you can get at that in your custom condition implementation. So you can get hold of the attributes on the annotation without actually having to load any of the classes themselves, so that you don't have to worry about kind of class not found exception stuff when you're trying to only switch stuff on if a particular class is there. So you can pretty much get as sophisticated as you like in terms of configuring your condition and making it configurable, as long as you can express that configuration in a way that maps to the types that annotation attributes support.
All right.
All right, so that was how to write a custom condition to kind of make your auto configuration as user-friendly, really, as you can. You can write nice error messages and things to help guide your users when things aren't quite configured properly. One last thing to understand about auto configuration is the ordering of the auto configuration classes themselves. So I talked earlier about the importance of auto configuration running after user configuration, so that the user configuration has a chance to contribute beans to the application context, so that when the auto configuration runs, it has the correct view of the world, if you like. But there's also the possibility that you might want to write multiple auto configuration classes that have some dependencies on each other. I gave an example earlier about us not auto-configuring Hibernate if there's no data source bean. Now, you can provide your own data source bean in a boot app. You declare a bean of type data source, and the data source auto-configuration will back off and get out your way and let you do that. But more commonly, you'll define a bunch of properties in application.properties to configure the auto-configured data source that will then be consumed by some other auto-configuration. So, for example, Hibernate auto-configuration or auto-configuration for a JDBC template. And we need to know that the data source bean is available before that auto-configuration runs, so that it doesn't get switched off when, in actual fact, if it had been run in the right order, the data source would have been available. So I want to talk you through how you can do that now. So here we've got, so this is a very simplified example where we've got some data access object, and it's using JDBC template to access the data. So this is an auto-configuration class that wants a single JDBC template candidate to be available to it. And it's going to use that JDBC template to create this data access object. We then have another auto-configuration class that is going to create a data source for us. So this one doesn't have any inputs, it just creates a data source. A bit of a simplified scenario, but hopefully illustrates the point. So this is an auto-configuration that is going to create a data source for us. And then lastly, we have some auto-configuration that's going to create our JDBC template, and it consumes the data source and uses that to create the JDBC template. So we've got these three auto-configuration classes. Data access auto-configuration is consuming a JDBC template and using that to produce our data access object. We've got data source auto-configuration, doesn't have any inputs, but it creates the data source bean as an output. And then we have the JDBC auto-configuration, which consumes the data source and produces the JDBC template. Now, if they just ran in the order that we can see here, data access auto-configuration, it wants a JDBC template, but we don't have one. So the side effect of that is no JDBC template on the way in, no data access on the way out. So we've now lost our data access bean from our application context. The data source one is fine. It doesn't have any inputs, and it will happily produce the data source for us. We then have our JDBC auto-configuration. It wants a data source, so that's fine. It can consume the one that's being produced by the data source auto-configuration, and it will happily produce the JDBC template. So what we need to do now is we need to order these three auto-configuration classes correctly so that they run in the right order, so that the dependencies are available. Each auto-configuration's dependencies are available when it runs. And to do that, we can use, there's a couple of annotations. So the first is auto-configure after. So auto-configuration classes are all ordered relative to each other. You can use absolute values, but ordering them relatively is a much more robust way to do it, because then you don't need to worry about what the absolute value is. So if that one was 10, then I need to be 11, or if that one was 9, I need to be 6, or what have you. You can just do it all relatively, and it should help to make that ordering more robust. So here we're saying the data access auto-configuration needs to be auto-configured after the JDBC auto-configuration. And that will mean that the JDBC auto-configuration has a chance to produce the JDBC template bean that our data access auto-configuration then needs to consume. Similarly, our data source we know that it needs to produce the data source before any JDBC-related stuff happens. So we can say it needs to auto-configure before the JDBC auto-configuration. And so these are the two annotations that you can use. You can either order stuff to go after other things, or you can order stuff to go before things. Whichever one you use, it will hopefully actually be fairly obvious when you're writing the auto-configuration, because it should be obvious that there's a dependency in a particular direction between the two auto-configuration classes. And so it should be obvious if the right way to express it is this one should go after this one, or if the right way to express it is this one should go before the other one. Another thing that might guide you is the package structure of your code. You might want to use one or the other to avoid having a cyclical dependency between your auto-configuration classes. Something else that you can do, I've shown here the two annotations are using class literals. You don't have to do that. You might want to reference an auto-config. You might want to run relative before or after relative to another auto-configuration that isn't necessarily on the class path of your project, of your own auto-configuration that you're writing. You could add it as an optional dependency or as a provided dependency, so something that wouldn't be pulled in at runtime but would be available at compile time. That's one way to do it. Alternatively, you can use a string. So you can use a string literal rather than using the class literal. You can just pass in the fully qualified name of the class as a string if you don't want or can't for some reason have an auto-configuration class on the class path of your own auto-configuration. So with those annotations in place, that now corrects the order of our auto-configuration classes. So we have our data source auto-configuration happily producing its data source bean. That can be consumed by the JDBC auto-configuration, which creates the JDBC template. The JDBC template can be produced, can be consumed by our data access auto-configuration, and it can create the data access bean. So, actually, one other thing on this slide I should mention. When you're ordering things, when you're ordering the auto-configuration classes, the order that they run in normally, if you haven't put any annotations on them to order them, isn't defined. It's not specified anywhere, and we make no promises that it might stay the same. Mm-hmm. It may well change if you run on a different JDK or on a different day of the week or at 5 o'clock on a Friday when you really want to go home. The order might change. So if you write an auto-configuration that has a relative dependency on another one, and it just happens to work before you put any ordering annotations on it, don't think, oh, good, that's nice, that's worked, right, done. I'll move on to my next piece of work. Be explicit about the ordering so that you know that it will be consistent and won't change if you run on a different JDK or whatever that may change the ordering. Don't rely on it if it just happens to work. All right.
Questions? Before we still have a few minutes, maybe, if you have questions on anything we've seen so far.
This annotation configuration properties, if I annotate a class with it, can it be created automatically?
So the
from string context, or I have to specify programmatically?
So the question was, if I have a class and I put configuration properties on it, can it be generated automatically?
Yes, that I can just auto-wire it without explicitly make a bean of it.
You can do so like any other bean, so you can.
It's a component. That's the question.
It will be if you say so.
It's already a component.
No.
So by default, a class annotated with configuration properties isn't a bean, but you can switch it on with the enable configuration properties annotation. And at that point, there's to get down into
there's
the technical
the post processor which looks for it and create a bean definition automatically. But if you want it to register as a bean, if that's your choice, you can do so and just add component on it, and that will do the same thing.
Okay. The other question of mine is enable auto configuration has a method to some auto configurations. I used it in a test configuration and it didn't work at all. I had to disable flyway auto configuration.
Mhm.
It didn't work.
So the question there was, so we didn't show it, but the enable
Yep.
auto configuration annotation, and in fact the Spring Boot application annotation has an alias for it as well, if I remember correctly. You can use an attribute on there to exclude particular auto configurations. So it's a not uncommon scenario if you're writing a Spring Boot app and you add a dependency on something, and it itself has transitive dependencies for something that it depends upon, but you're not really going to use in your app. And that could cause Boot's auto configuration for the thing that's pulled in transitively to kick in when you don't want it to. So you can explicitly say, if you want to keep auto configuration switched on because it's doing the right thing 99% of the time for you, in a situation where there's something on the class path that you don't actually want the auto configuration for to be enabled, you can use, there's an exclude attribute on Spring Boot application that you can use to switch it off. The question here was that it was used you used it in a test, and the exclude attribute had no effect.
Depends how you've started the context, I would say.
Yeah, so
if you start a context like I did,
Annotated with test application, blah, 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 application as a class, as a method param.
I think we probably need to see the code.
Maybe I will make an example.
Yeah, one possibility, just for the broader audience, one possibility is that the test was finding two classes with enable auto configuration on them, one that had the exclusion, one that didn't. I don't know if that was your case, but that is one situation where that can happen.
I can think of anything else.
There is no known bugs right now.
No.
Okay.
Any other questions before we... Yes?
Do you still use profile or just conditional?
So the question was, do you still use profile or just conditional?
So profile is a condition, actually. It's exactly the same thing. So profile, if you look at profile now, I'm going to answer the question, but just for the... this is what profile looks like now. Profile is just a condition on profile condition, and profile condition is just looking if a certain profile has been set. In a Spring Boot app, do you only use conditional or profile? I think for your own config, it totally makes sense to still use profile. If that works for you, there's no reason to switch to anything else.
In an auto configuration, it's probably less common.
Yes.
That you do. You might use it if you wanted to document in your auto configuration that you have profile A and profile B, and people can pick which one to use, and that'll change your auto configuration. You can use profiles in auto configuration. There's no reason why not. But
it's a condition, so it will work.
It's probably less common, though, I would say, and it's more likely and fully encouraged in a Spring Boot app in your own kind of app user code. If profile is doing a job for you, then absolutely use it. It's still very useful for that kind of scenario.
Usually, you would use the conditions that we have in Spring Boot are much more powerful than just profile, because you need to enable something. It's a string, so it's not really very descriptive. You'll find that the conditions that are available in Spring Boot allow you to figure out what you need to do more easily than just with the profile thing. So usually in auto configuration, you'll probably won't use that indeed.
All right. Any more questions before we have a break? Yes.
It's my impression, right, that basically the auto configuration is done before all the auto wiring and post-processing hooks are involved. So basically all the beans are created in the first place. First the user configured ones and then the auto configured ones. But after that only all the auto wiring and post-process hook invocation is done.
Mm-hmm.
So the question was, did you get the correct impression that the auto configuration runs before any auto wiring and post-processing happens of any beans? And yes,
Yes.
that is correct. So the when your app starts up, the user configuration is looked at, and we find all of the components and beans declared in configuration classes, and we create bean definitions for them. So not beans, but bean definitions for them in the bean factory of the application context. The auto configuration then runs, and we create bean definitions for those. And at that point, we've now got a complete view of all of the bean definitions, and then dependency injection can happen, and post-processing and proxying and all the other stuff that happens as part of the refreshing of an application context. Time maybe for one more question before the break? Yes?
I noticed you left out the auto-wired annotation, for instance, for constructor dependency injection. Is that the new recommended way to pay no optional Spring 5?
Spring 4.3 actually. So the question is, you use constructor injection, so maybe show that in action. This is actually doesn't contain the auto-wired annotation. You've probably noticed that. As of 4.3, this is no longer necessary. So if you have a bean with a single constructor, we will use that by default for auto-wiring. So you don't have to specify auto-wired again. If, however, I'm adding an extra constructor to this class, I will have to put auto-wired to tell the container which constructor it has to use. Is it the best practice now? I think it's a matter of taste, really. It just became redundant. So if you want to add it just to signal the fact that that's the thing which is going to be used when the bean is constructed, feel free to keep it like that. One nice thing is it's one less Spring-related annotation in your code. So you can actually write classes that do not have any Spring imports at all that way. So that's why we made it like that. And it also some nice stuff with Lombok, I think, because Lombok requires you to write crazy annotation to add the auto-wired on the generated constructor. This is no longer necessary thanks to that.
Another nice thing that came in Spring Framework 4.3, as well as not needing the auto-wired annotation, you can now use constructor injection in configuration classes as well. You don't have to use field injection.
Yeah, which is the case here actually. So this is as from Spring Boot 1.4, which uses Spring Framework 4.3 behind the scenes.
Or you can, if you want.
Oh yeah, you can use Spring Boot 1.3 and upgrade. Yes.
Yeah, you can, if you want to. If you're not ready to move to Spring Boot 1.4, but you want to take advantage of some of the goodness that's in Spring Framework 4.3, you can override the Spring version property in your POM or your Gradle script, and Spring Boot 1.3 will run fine on top of Spring Framework 4.3.
Okay.
Should we have a break? All right. Welcome back, everybody. Hope you all enjoyed your break. Managed to grab a coffee. Let's launch into part two. So we've got 2 or 3 things that we want to kind of carrying on from the first part, talking a bit more about the life cycle of what happens when you start up a Spring Boot app, and then we're going to talk about some of the new stuff that's in Spring Boot 1.4.
Okay, so we have now 2 or 3 demos prepared for you to really focus on how you can hook into the application startup. One of them is customizing the environment. So you're using Spring Boot, you probably know that there are many places where you can specify configuration. So you could have values in that file, or maybe a file at the same location as the jar. If you run the repackage archive, you can put an application properties next to the jar, and it will be picked up by default. You can specify command line switch, system properties, what have you. And you can also customize the list of files that we look into rather than using the default. But maybe you want to do more and be able to automatically, for instance, look for a file at a certain path, and when you find it, just customize the environment with its content. So let's do that. And Spring Boot actually offers you a hook point called environment postprocessor that allows you, like you guessed now, to customize the environment. So one use case would be to look for a file in your home directory. that would contain development-specific settings, and just use those rather than the default specified at the project level. The thing which is nice about it is you can actually also customize where that new property source is going to be added, so you get a chance to determine how it can be overridden. So the environment is made, so environment post-processor gives you the configurable environment and the application that's currently starting. Configurable environment allows you to get the list of property sources. So a property sources is basically a list of keys that came from some location. So there's one property source with the system properties, one with the command line switch, etc., etc. So in this case, what I do is I'm looking for a file in the home directory in .lo/settings. And if I find that file, I'm basically loading it, and it's supposed to be a property file, but it could be anything. I'm loading the content of that file, and I'm adding a new property source that I want to add after, if I remember correctly. Is it after or before? After the command line property source. So basically what that means is everything which is before command line switch, including command line switch, can override that value. Otherwise, that value will take precedence.
And the way that works is when you're trying to retrieve something from the environment and you ask for the value of a particular property, all of the property sources in the environment are checked in order. And as soon as we get a non-null value back from a property source, the search stops at that point. So the earlier the property source is in the list, the higher precedence it has.
So again, how do you make sure that that thing runs by default when you add that jar to your project? So this is currently in the application itself, so it's not very interesting. But you could move that to a shared library, and whenever that library is present in your application, that environment post-processor is going to be called. So let's run the application again. And I can see that my message has changed again with Hello World. And if I'm looking into the content of my Hello settings, this is what it contains, right? So it's a very easy way for you to customize the environment. There is one more trick. Let's switch this application to a web application for a second, just to show you something. I'm going to add the actuator. And for
the few of you who are new to Spring Boot, we talked a bit earlier about the actuator and providing access to the auto-config report. The actuator is basically an optional module in Spring Boot that adds a bunch of production-ready features to your application. So it has metric support in there, for example, for gathering performance data about your app, and also provides endpoints for things like looking at your application's beans, looking at the configuration properties, the auto-configuration report. And you can just drop add a dependency in your POM or your build.gradle. If it's a web app, it makes the endpoints available over HTTP. If it's not a web app, you can also get that information via JMX as well.
What is the endpoint again for the auto-config thing?
Auto-config with no dash.
No, that's what I wrote. No, that's not what I wrote. Okay, whatever. The nice thing is what I wanted to show you is the environment. And there's a trick with the environment that actually I happened to understand it while preparing this talk, which is always funny. So the list of property sources here, so each element in the output is a property source. So if we go back to the code, we can see that we named our property source hello local. That's the name of the property source, right? Then you find back this hello local here with the value. And you find also all the other property sources in this particular environment, including the ones which is read from the root of the class path. The trick is the order in the JSON is actually the precedence order as well. So if you want to figure out if I have like 2 hello prefix value, which one is going to be used, it's simply the first one in the JSON. So if I'm adding, and that's the demo I was supposed to do, if I'm adding a command line switch now, so I'm changing the value as a command line property. So basically this is a feature of IntelliJ, but this is the same thing as writing this.
And I think actually the latest Spring Boot tooling in STS has a similar thing for adding the kind of the not just the program arguments kind of plain text field. It's got the kind of the key value table thing that IntelliJ has as well.
Why? Oh, because obviously. Okay, it's to start with a capital now. So my app will start, the message will change, and as you can see from the output, the command line arguments is, so hello local, if there is a command line argument, property source will be added after, which means that anything that's defined before is going to take precedence.
Another handy thing with the env endpoint, I don't know if there's an example here, but it will automatically obscure any, so if you have like a key that's, sorry, there we go. So it looks for certain words in the property key, so things like token or password, and if it finds one, it obscures the value so that your env endpoint doesn't leak credentials that you might have configured your app with. And you can, there's a default strategy for sanitizing the values and obscuring them. If you use a different convention for the keys, you can plug in your own sanitizer to make sure that you're not leaking anything out in the endpoint. You can also secure the endpoint as well, but it's kind of a nice extra thing to make sure that you don't accidentally leak a shared secret or something.
Yeah, talking about secret now, everybody knows I'm using Ruby, so that's really a problem. Right.
All right, so that was how to customize the environment. We'd now like to talk a little bit about what happens when your application starts up, and that kind of ties into how the environment gets set up and when an environment post-processor runs. So when you start a Spring Boot app, so this is when you've called run on your Spring application, one of the very first thing that happens is that the application started event is published. And at this point, we initialize the logging system. So this is basically saying to the logging system, you're starting up, get ready to start logging stuff. The next thing that happens is that an application environment prepared event is published. Now this means that the environment has been created and contains the default set of property sources. So this is the standard list of property sources that you would get in Spring Framework's environment. So there's, at this point, nothing boot specific has happened to the environment. So if my memory serves me correctly, there will be 2 property sources in there, one for environment variables and one for system properties. So once that environment has been created, your application context hasn't been created at this point. No beans have been created. The context certainly hasn't been refreshed. This is still really early in the application's life cycle when we're just preparing stuff and getting things ready to, and then we'll begin to start things up. So at this point, we read in the config file. So this is where Spring Boot specific stuff starts getting added to the environment. So this is when we read application.properties and application.yaml, and the profile-specific variants of those. For those of you who aren't particularly familiar with Spring Boot, you can make a properties file, either the actual property file or the YAML file, profile-specific, so rather than calling it application.properties, if you call it application-profilename.properties, that properties file will only be read when the profile that you're referencing in its name is active. So it's a way you can enable a profile, and that can switch on some beans because you've used that profile on a configuration class, for example. You can also switch on specific configuration in particular profiles. So you might have like an application-dev.properties, which sets some stuff that you only want at development time, maybe switches on some debug logging or tells Hibernate to spit out the SQL commands it's running or something like that. So the config files are all read, and property sources, one or more property sources, depending on how many files are found, are added to the environment. And this is where the ordering comes into play, because we're adding multiple property sources to the environment. So for example, a profile-specific property source takes precedence over one that is just general, isn't profile specific. So the profile specific property sources are added before the general one for your plain application properties or application YAML file. So at this point, the environment has been set up and it's now in its default form for Spring Boot. So it has the property sources that Spring Framework provides. So it's got the property source for environment variables and the property source for system properties. It's also got those that Spring Boot's added from all the config files that it's read in. And then that environment is passed in, and the property source for command line arguments. That environment is then passed to all of the post processes that are configured in Spring.Factory. So we just saw Stéphane wrote one, and that added in the property source for the hello settings, and he ordered it relative to the command line arguments property source that Spring Boot had already added. So you're given, your post processor is called with the environment in kind of a well-known form and with a well-defined set of property sources available in it. And at that point, logging initialization completes. And the reason it doesn't complete any earlier is that you can configure your logging settings in the configuration file. So there's kind of a chicken and egg thing here, and we have to have read those files in before we can say to the logging system things like, for example, here's the pattern you should use for console logging, or these are the log levels that you should use for logging output. You can configure all of those in application.properties or in any input to the environment. So environment variables, system properties, command line arguments, all of those things contribute stuff to the environment, and then we use those values to complete the initialization of the logging system. So the next thing that happens is that we fire the application prepared event. So this is basically Spring Boot saying, I've done all of the setup. The environment's all been prepared, and we're ready to go now. And at that point, we refresh the application context. So this is just the standard. We just say to Spring Framework, to the application context type, we say refresh. So it's at that point that things start happening, that beans start getting created, dependency injection happens, etc. As a result of that, the context refresh event is fired. So this is just Spring Framework's standard context refresh event. There's nothing Spring Boot specific about this one. All the previous events that I talked about, they're all Spring Boot specific, and you'll only see those in a Spring Boot application. This one, the context refresh event, this is just standard Spring Framework event that is published when the application context has been refreshed. So there's an interesting subtlety to the application startup that I think is worth talking about a little bit more. So when you're running Spring Boot with an embedded container, as we recommend, the container it's basically a bean in the context, and it's started up as part of all of the beans in the context being started up. But we deliberately don't start the connectors for the container as part of its bean actually being started. And the reason for that is that we want to know that the application context is completely up and running and refresh was successful and everything is in a good, well-known state before we start accepting HTTP requests, before we let Tomcat or Undertow or Jetty start handling requests, because we don't want a request to come in and us to try and pass it into the dispatcher servlet when it's kind of halfway through being initialized, or perhaps it's initialized but some of your controllers aren't initialized. So we deliberately defer starting the connectors for the embedded container until the context has been refreshed and we know it was successful. And we then call the embedded container and say, right, now start listening on whatever HTTP port is configured and start accepting requests and dispatching them to the dispatcher servlet and then into the rest of your application. So at that point, when the connectors have been started, we fire another event, the embedded servlet container initialized event. And you may have seen in Spring Boot's integration testing support, you can start the container on a random port. If you configure it and say just use 0 as the port, that basically says, that goes right the way down to the TCP/IP stack in the OS and basically says open a server socket on any port that's available. But you need that. You need to know that port in your application because you need, say you're using REST template to test something, you need to know which port to try and connect on in your REST template. So the embedded servlet container initialized event is the point when we know the connectors have started, and so therefore if you were using a random port, we know what port was allocated, and at that point we can then, it actually updates the environment and adds a local.server.port value to the environment variable, to the environment that you can then consume in your tests if you're testing on a random port. Reason why you might want to test on a random port is it means you don't really need to worry about port clashes in your CI environment or on your dev machine. You don't need to say, right, nobody have anything running on 8085 for example, because that's what port our tests use. If you just use a random port, you don't need to worry about a port clash. The OS will allocate you one that's guaranteed to be free. So it just makes your tests a bit more robust and a bit easier to run in any particular environment. And then last of all, we've published the application ready event. So that's just basically saying everything's done now. The context is refreshed. The servlet containers connectors have been started. We've published the local server port property, and you can do whatever you need to do now that everything is all up and running. So that's all of the events and when they're published. But now let's take a look at how you can consume those events in your application.
Right. So consuming in such event, the events that are fired is really a standard Spring Framework event. So for that you can use, and you can implement application listener simply, which is what I'm going to do now. Here we go. And I'm going to implement application listener for no particular event. I'm going to use the application event based class. The reason why is I want to basically handle all events in this particular case. It doesn't do anything fancy. It's like just adding the type of the event so that we can see what's happening. So again, you want to register that and make sure, the typo. You want to make sure it's going to be picked up automatically. What could you do? Well, you could do that, right? But if you did that, most of the events will be missed because all the events that will be fired before the application context is actually refreshed will be fired without that being to be created in the context. So don't do that if you want to listen to early events. You need to register your class in a different way. You could register it here if you wanted to. Again, the fully qualified name of the application listener interface, and as the value the comma-separated list of implementations. But in this case, I'm going to use a different way and show you how you can do that with the Spring Application Builder. So Spring Application Builder is a way to customize the application before it starts. So you still provide the source, and then you get this nice completion with plenty of things that you can customize, and listener is one of them. The advantage also doing so that way is that you are in charge of actually creating the instance. So the Hello Application Listener class is created by you, and you can pass any value that's necessary. And I can, when I'm done with all the customizations, I can basically run the app.
You need a semicolon.
Do I? Okay. So if we run that app again, then we will see a bunch of events being fired, like Andy explained. The application started event is the first. Then we prepare the environment. We can see that the environment has been prepared here, so you may wonder where that comes from. We actually buffer some logging events, so we actually keep those log events somewhere until the logging system is fully initialized, and then we replay those log events so that you get those information. At this point, the context is actually refreshing. So this is where we actually start the application context. It's done here. We have the context refreshed event from Spring Framework, and we can see that the connector is started on 8080. Application embedded servlet container initialize event, is fired. Then we run the command line runner at that point once the application has fully initialized, and then we have the application ready event. Right. So we've seen those. Let's see now in more details.
Yeah, so
how that works.
We saw a few times while we were going through the presentation, Stéphane showed you a couple of times a kind of a nice error message that appeared during startup, for example, when the prefix was wrong, the hello prefix. We got a nice little message coming out rather than a stack trace, and that is Spring Boot does that thanks to something that we call a failure analyzer. And basically, what a failure analyzer does is when your application starts, if an exception is thrown, it catches the exception, and then all of the registered failure analyzers are past that exception and given an opportunity to kind of analyze the exception and turn it into something a bit more useful. So rather than just throwing a stack trace in your face, we try to extract the useful information from that stack trace and present it in kind of a more consumable form and maybe make a hint or suggestion as what you can do to fix the problem. And there are a bunch of failure analyzers available out of the box in Spring Boot. So no such bean definition. I think we saw that earlier when we were working on the hello auto config and the bean wasn't there. So we got the nice little message saying there's no bean of this type available. There's also one for bind exceptions. So that's if some JSR 303 validation failed. So for example, you can use validation on your configuration properties classes. And if that goes wrong, you don't really need a great big stack trace. What you actually need to know is, I was trying to bind this value to this property, and it didn't work because these bits of the validation failed. So that's what it'll tell you. Being currently in creation, circular dependency. We'll see in a minute we can do some good stuff with that. No unique bean definition. So this would be if there are multiple beans of the same type, and you're just looking for one, you're not trying to inject a collection of those beans, then we can tell you were looking for one bean of this type, but actually we found 3. These are where they came from, so we can tell you which configuration class or XML or wherever they came from. Port in use, hopefully fairly self-explanatory. If you start your boot app and something's already listening on the port that you're trying to connect to, you don't really need a stack trace from down in the depths of Undertow telling you that I tried to start a server socket on this port and it wasn't available. What you actually need to know is, port 8080 was already in use, and you either need to change your config or you need to figure out which process was running on that port and stop it. And also data source bean creation, which is, so Spring Boot will attempt to auto-configure a data source for you. And sometimes it'll look as if you're trying to make use of an embedded in-memory database, but something isn't quite right. We do failure analysis of that exception to try and guide you in the right direction and help you to correct your configuration. So let's have a bit of a look now at the being currently in creation. So this is a real-world example. Imagine one day you start your Spring Boot app and you are greeted by this. I'm sure you've all already have read that and you figured out exactly what the problem was. So you can see there, it is an enormous stack trace. 248 common frames omitted. So it's a huge nested stack trace that weighs in at 340 lines. And what it's trying to tell you is that there is a cycle between some of the beans, 2 or more beans in your application context. Their dependencies mean that as the core framework was trying to create them and inject dependencies, it got to a bean that needed something that was already trying to have dependencies injected into it. So there was a circular dependency between all of those beans, and the cycle couldn't be broken. That's what it's trying to tell you. Instead, it just vomits 340 lines of stack trace and says, there you go, you deal with the problem. We didn't like that very much, so we decided to get rid of that and replace it with this. So this, we should acknowledge the Elm programming language's compiler has some phenomenal error messages in it and error support in it that will, if you have a cycle between modules in Elm, it will produce you a really nice kind of diagram like this that says there's a cycle. So hopefully here you can see, and this is a particularly complicated example of a cycle. This was from a bug in Spring Boot 1.2 or 1.3, I think, where we had inadvertently created a cycle among a number of beans in Spring Boot itself. but it only happened if you were using JNDI and you were consuming a data source from JNDI. So it took a little while for someone to find it, and they opened an issue and they gave us that 340-line stack trace, and we really wished we had something better, because it took a long time to figure out what was going wrong. Hopefully this makes it much clearer. So you can see the 3 lines at the top. We're kind of going down. This is just kind of the dependency chain before we actually get into the cycle itself, which starts with the object mapper. And then we go down through a bunch of beans, and we end up with something in Spring Boot's actuator. So as I mentioned before, the actuator can expose stuff via JMX or HTTP. And in this case, this is the piece that is exposing the endpoints over JMX. And it needs the object mapper to convert responses into JSON. So the JMX endpoints send their responses as JSON strings, similar to how the HTTP stuff does. And there was a cycle among all of those pieces. So you can get this kind of hopefully helpful output out of an app when you start it up. And I showed you the slide earlier. We had, I think it's about 6 or 7 maybe, failure analyzers available out of the box. If you, while you're working with Spring Boot, if you're regularly encountering a problem at startup and you're greeted with a stack trace rather than something helpful, please, please, please do open an issue and say, you know, here's a sample app. When I start it, it does this, and the bit of information that I actually needed was whatever, and we will very happily add another failure analyzer for you. And you can also, if it's a failure that's in your own code, say you do run some business logic or something at startup or whatever you might be doing at startup of your app, you might want to give your users or your fellow developers a bit of an easier ride if something isn't quite set up properly. And you can write your own failure analyzer to give people, to provide more helpful messages. And Stéphane's going to show us how we can do that now.
All right, so to be able to demonstrate that, I'm just going to check in the next commit. And that next commit is going to change our project a bit to, rather than not exposing the hello service if the prefixes start with a lowercase letter, throw an exception. So as you can see, the custom condition that we wrote is gone now, because the only thing that we need to do really is to check if the hello prefix property is set. So if it's not present, then we shouldn't configure the bean. And if it is present and it starts with a lowercase, we should throw an exception. So if we go back to the auto configuration, sorry, we've replaced our custom condition with this, which is a Spring Boot standard condition that we already described earlier. And in the code itself, we can see that we have this exception now. Having a dedicated exception type is quite important if you want to write a failure analyzer. You could theoretically write a failure analyzer for illegal argument exception if you wanted to, but you'll need more work to figure out if that's the right illegal argument exception, if this is the one that you should actually handle. So what does it take to create a failure analyzer?
Do you want to run it first and see what it looks like without the analyzer?
True. We need first to see it's ugly. Otherwise, it's no fun. Okay. So let's put a lowercase c in here and restart the app. So welcome, right? So what you get is you get the 3 exception types that are related to the container trying to do things and giving you the context of as to why that exception was thrown. So the application context, when it fails, it's not going to simply throw the lowest exception types. It's going to give you context as what it was trying to do. In this case, it's telling you that it can't create the command line runner bean because it couldn't create the bean named hello service. And it couldn't create the bean hello service because that thing threw an exception, and that exception happens to be this one. Now that you know what's going on, and we all know the context, okay, some property was set with a lowercase character, all that doesn't matter anymore, because all you need to do really is to have a quick message telling you that property was set with the wrong value, and maybe specifying the value would be nice because maybe you forgot about the local development settings and you put a wrong value in there and you don't remember. The fact that you see the actual value that was tested will help you to track down where the problem came from. That's why you need to have a dedicated exception so that you can really inspect only and check only for that exception type. And usually you'd like to add some metadata, some additional information to the exception. As a matter of fact, the failure analyzer that we've built in Spring Boot led to some changes in some of the exception types to expose more metadata so that we can read and provide a better description of the problem. All right, so let's go and create our own failure analyzer. Might have a template for that? No, I don't have a template for that. Too easy. Invalid hello prefix failure analyzer. So in this case, I could implement the failure analyzer directly. Remember, condition, you extend from Spring Boot condition to get the ability to contribute things to the auto configuration report. In this case, we also have a base class that helps you. And that base class actually allows you to give the generic type, allows you to give a generic type, sorry, which is the exception that you're looking for. And what the base class is going to do is, if it will inspect the stack trace, and if it finds amongst the nested codes one that matches the type, it will call you. That you don't have to do that yourself. So the contract is basically to run any kind of super complex logic in there. So for this, so no such bean definition exception, what we do is we get the auto configuration report. We actually inspect the auto configuration report for the things that match the type of the bean that did not match. We extract the message and we add that to the report so that you can immediately see what could go wrong. If you can't handle the failure for whatever reason, because that invalid hello prefix exception is in such state that you can't do anything about it, you can just return null, and it will give a chance to another failure analyzer to maybe handle that. In our case, we can just return the failure analysis right away because it's very easy. So failure analysis is a simple object that takes a description, an action, and the code, so the actual exception that was thrown. So whatever.
You can also, similar with lots of other things that we've said where you're plugging stuff in, you can order your failure analyzers as well. So you can implement ordered, or you can use the ordered annotation and control the ordering that your failure analyzers run in. And as Stéphane said, if you can't handle something, just return null, and then the next analyzer in the list will be given a chance.
Okay, whatever, right? And then the code. The reason why we have the code, did you say that and I was not paying attention?
I didn't.
Okay. You didn't, okay. So the reason why you pass the code is if you start the app in debug mode, we will also print the exception in that case so that you can see the full context in case you need that.
Which can be handy if the analysis wasn't as helpful as it thought it was being, and you'd actually quite like to see the place where the actual stack trace and actually where the exception originated. So if you just run with debug, just start with --debug, then it'll log the exception and you'll get the full stack trace again.
So if you want to test that, it's also very easy. You need to create an exception that matches certain things that your failure analyzer is supposed to do. You get a failure analysis object, and then you can inspect if the failure analysis contains the things that should have been added to it.
And there's examples of that in boot source. If you're interested in seeing how we did it, we've got tests in there for all of the failure analyzers. So they'll deliberately start a context when there's a bean missing, for example, or when there's deliberately a cycle between beans, and then we assert that the analysis contains the information that we expect it to.
So again, you want to make sure that that thing runs transparently, that your user don't have to import a certain class or add some configuration or whatever. You want that to run smoothly. You can register the failure analyzer in Spring Factories. Again, a fully qualified name of the interface you implement and your implementation.
one thing here that actually it wasn't this way to begin with, and it was it broke the failure analysis until we fixed it. We now load the analyzers defensively. Each analyzer that's listed in Spring.Factories is loaded in a try-catch. So if the thing that tripped us up was the analyzer for JSR 303 validation failures depended on the validation API being on the class path. And if you started an app that wasn't using Hibernate Validator or whatever, we'd try and load the failure analyzers, and the one for the validation failures would throw a class not found exception because the validation stuff wasn't on the class path, and that broke all of the failure analyzers. So we fixed that now, and they're each loaded defensively individually. So it's something you don't need to worry about in your own analyzer. If it depends on types that may or may not be there, then if they're not there, then it won't break anything. It just means that your analyzer won't run.
So let's run the app again and see what happens. And this is what you get, right? Expected. So rather than a stack trace, you get now a very helpful description, I might say. And what's really interesting is you actually get the things that was wrong, so you get a chance to understand where that's coming from.
All right.
Right.
So that's I was going to kind of switch tack a little bit now. So that concludes the kind of the deep dive into the magic that's under the covers of Spring Boot and everything that goes on during startup. And we'd now like to talk to you a bit about some new stuff that's in Spring Boot 1.4, which tries to take some of the productivity gains that auto configuration gives you for your main code and tries to do the same for your application's tests. So it helps you reduce the amount of boilerplate and lets you focus on actually testing your business logic rather than setting stuff up to test your business logic. So the way we're going to demo that is we've got an existing Spring Boot app that is using Spring Boot 1.3, and we're going to show you, kind of walk you through migrating it to use Spring Boot 1.4 and take advantage of some of the new features.
Right. Okay, so we can get rid of that. So let's start by looking at the application, what it does. This is an application I borrowed from another talk. If you're interested by the application itself, you'll have the link at the end of the session. So this is a very simple call for paper app, nothing fancy. It has an integration with GitHub showing you the latest commit. If you were on the university session this morning, this should ring a bell. There is also a way to submit a new proposal. You don't need to log in, you just give your full information, whatever. And once you've done that, you can also access to an admin section. And the admin section allows you to look at the submissions that have been created. And you have the actuator running behind the scenes, so you can actually look at your database, etc., etc. So it's a JPA-based application with some security settings, which are like at that stage of the application are quite simple. And there are also a bunch of tests that test all the layers of that app. So let's run them and see what needs to be done to migrate to 1.4. So the first thing to do, so we'll look at each of those tests and see how we can improve them. First thing I want to do is to change the dependency in here and run the test again to make sure they still work. And as I do, I'll get some additional compiler warnings because things have been deprecated in 1.4 that I'm using. So let's see what I can do to fix them. Do I need to fix a test now, or do we have some slides? I don't?
You carry on.
Okay.
Let's get rid of those deprecation warnings.
Good. So the first test we want to show you is a test for a controller. It has a deprecation warning on Spring application configuration. We'll explain you in a minute why. So let's look at the boilerplate that you have to write to actually run that test. First of all, you need to give it a context. So you need to tell it how to start the application. In this case, we simply refer to the application class itself, right? We have an extra class. We'll see that in a minute what it does. Then I need to tell to Spring Boot that it's a web app related test by using the web app configuration, and that's going to make sure to create a web application context. Next up is setting up mock MVC. To set up mock MVC, I need to have a reference to the web application context, so I need to inject that and basically configure mock MVC like this. So it's a one-liner, but stuff that you need to know, you need to be aware of. The next feature is, and that's what that test config is all about, is we don't want to, when we submit a new proposal, we don't want to actually have a database. We don't want to store the data actually in the database. We just want to make sure that when we do that post, the attributes are properly parsed and the proper submission is created. So in order to do that, we are creating a mock here that we run after the application. The order is important here. Because it runs after, it's going to override the submission service that has been scanned by this CFP application, right? We only have one test, but let's say that you have more than one test. You need to make sure that every expectations you have on your mock are reset at each test. So that's what I do here. I'm using a Mockito feature to reset the mock before each test starts. And the test is very simple. I'm creating a submission request. I'm just expecting that if we create a request like that, it will work. I'm posting to the endpoint, and I'm making sure that the mock has been invoked, right? So let's see what it looks like to do the same thing with Spring Boot 1.4. The first thing is I'm going to use a dedicated annotation to tell that I'm writing a test for WebMVC. We'll explain you in a minute what it does. Then I'm passing the controller that I want to use. Because I'm telling it's a web MVC test, there is no need to be redundant and say again it's a web app configuration. So I can remove that line. Because it's a web MVC test, some auto-configuration for testing will kick in. And one of the things it will do, it will auto-configure a mock MVC for me. So because it does that, I don't need to inject this, and I don't need to do this anymore. The next thing is I can use a new feature in 1.4 to automatically mock bean, and the way to do that is to add mock bean to your to a field. What that will do, it's going to either replace an existing bean with that type in the context, or it will create a bean of that type. It will create a mock in the context for that type. So I can get rid of that.
There's also a excuse me. There's also a spy bean annotation. So if you want to create a spy rather than a mock, you can spy on an existing bean, for example, in the context using the spy bean annotation.
So if we run the test, it will fail, and it will fail because we need to be authenticated now. So you've seen me actually submitting something without being authenticated because our security config actually configures that. What's really important to understand with this new annotation is that it's going to change the way class path scanning works. And in this case, it's only going to scan that class and web-related components that might exist in your application and nothing else. What that means concretely is the security config here that tells that submit is public is not even considered at all. And we fall back to the default behavior of Spring Boot, which is to secure everything. So I could do many things to fix that. I could decide that I don't want to run with security. And my test will pass now because that constraint is no longer applied. Or I could compose my context and import an additional file. So tell Spring Boot to scan an extra class for this particular test. So that's a lot of boilerplate gone now. Rather than setting up the infrastructure yourself, you're telling this is a test for X, and you'll get nice test-related beans created for you automatically. So let's see that in more details.
So the app that Stéphane just described, the Call for Papers app, if you kind of look at the diagram here illustrating its construction, there's kind of two different columns of functionality in the app. So there's the submission piece. So we just saw the web controller for that. So that's sitting on the top, on the left-hand side, which is sat on top of the submission service. And then beneath that, we've got some Spring Data JPA based as a Data JPA repository. On the right, the other column of functionality, there's a bit in the app that shows some information from GitHub, some latest commits from Spring Boot and Spring Framework. Again, there's a web controller kind of slice sat on top of that. Beneath that, there's a slice that is the GitHub client, so that's using REST template to make some calls out to GitHub. And then there's the kind of the GitHub API sat beneath that. So we've got two columns of functionality, and then in each column we've kind of got slices layered one on top of the other that are providing different parts of our application's functionality. And we can take advantage of this structure when we're testing the app. And it's kind of it's kind of a virtuous circle here, if you like, because the more that you structure your app and segregate things and keep areas of functionality separate and layer them nicely, the more amenable your app is to this new approach to testing, where you're testing an individual chunk, an individual slice of a particular column of functionality in your application. So we can look, we've got two web slices in the application. We've got the controller that handles the submissions, and then we've got the controller that also surfaces the GitHub commit information. We've also got another slice of it, which is the submission service. It doesn't really doesn't have many dependencies. It's very amenable to unit testing because it's just taking a request in for something and then possibly using a data JPA repository, which is very easily mocked because it's an interface. We have the GitHub client piece. So this is using REST template. So we've got a chunk of code that's making HTTP calls out to GitHub's API. We've got improved support for testing that. And then sat down at the bottom, we've also got data JPA. So we've got a bit of functionality in the app that's using Spring Data JPA, sat on top of Hibernate, talking to an SQL database. So
that's what we did.
You did that. So you saw web MVC test. So we had a web piece of the app, and we wanted to test it. So Stéphane used the new web MVC test annotation. I want to talk you through now to kind of help you understand what's going on under the covers, everything that it's doing for you, so that you can, when you hopefully use it in your old tests, and you can get rid of all the boilerplate, as Stéphane just showed you, understand why you can get rid of that boilerplate and what it's doing for you. So the web MVC test annotation is actually, it's meta-annotated with a bunch of other annotations. So the first thing that we do is we override the auto-configuration. So this is basically saying, I don't want all of Spring Boot's auto-configuration to be switched on. I'm just testing a web piece. So we don't want to bother auto-configuring a database or Hibernate or anything else that isn't related to the web part of our application. So with this annotation in place, even if we encounter enable auto-configuration annotation somewhere, it won't have any effect. We've overridden that, and we're saying we don't want any auto-configuration. The test slice wants to have control over what does and doesn't happen. Stéphane mentioned that you're only going to get some bits of your app, some beans created. And we do that using a type exclude filter. So there's one specifically for web MVC test. So this will let in, hopefully, everything that you'd expect in a web-related test. So it's controllers, it's REST controllers, it's Jackson Object Mapper for JSON serialization, it's HTTP message converters. It's all the kind of things that you'd typically expect to use directly in the web layer of your application. It will exclude things like JPA entities, because we don't expect them to be used directly in the web layer of your application. we enable caching auto-configuration. Well, we customize it, and we switch on a no-op cache manager. So that if you're using caching in your app, it quite often is something that cuts across the whole app when you have caching enabled. But when you're trying to test something, you don't want the cache to get in the way. You want any calls that you make to actually make it to the thing that you're calling rather than to be intercepted by the caching. So the auto-configure cache switches on caching, but with a no-op cache manager that just passes straight through to the thing that's being called.
And you can customize that if you want. So if you want caching, there is a way to use auto-configure cache with a strategy, not to replace it, but to use the one that exists, if any.
As you'd hopefully expect, we auto-configure web MVC. So that kind of switches on a number of the things that I described when I was talking about the type exclusion filter. So it switches on auto-configuration of the dispatcher servlet, of your controllers and REST controllers, object mappers, HTTP message converters, etc. And then we also auto-configure mock MVC. So we saw that Stéphane was able to delete all of the boilerplate for configuring mock MVC. That's powered by the auto-configure mock MVC annotation. So that creates, using the application context that's configured in your tests, we create a mock MVC instance that's using that application context. And then you can have that injected into your test, as you saw, and then just start using it rather than having to bother yourself with setting up all of the setting it up and configuring it and having the application context injected, et cetera, et cetera. So trims your tests down and means you spend less time on boilerplate. All right, so that was the web bit. We also have support for testing kind of a data JPA-related slice of your application. We know our Call for Papers app makes some use of JPA to store the submissions. Mm-hmm. So let's see. Shall I describe it, or do you want to show it?
Doesn't matter.
Okay, I'll describe it.
Okay.
And then we'll show it. So we've got data JPA test. It does a very similar job to web MVC test. It switches off auto-configuration again, and then it has its own type exclusion filter. So very similar to the web MVC one, does exactly the same job, just for data JPA-related types. So we're going to do entity scanning now. Hibernate's going to get started up. Your database, so say you're using H2 database for your test, that's going to get started up. Whatever you're using, anything data access related is going to be included when everything's scanned. Caching, again, special setup for caching so that caching doesn't get away in the way of your test. Exactly the same behavior as we described for web MVC test. Auto-configure data JPA, so this turns on the auto-configuration for Spring Data JPA, so all of its goodness where it looks for data JPA repositories and then auto-generates stuff for you based on the signature of the methods on them. All of that will get switched on for you.
Flywheel Cubase also will be switched on.
Oh, yes. Yep. Auto-configure a test database for you. So you might be running your app and you might be configured normally to talk to Postgres or MySQL or whatever. You can also, instead, you might want to use a test database. So we'll set up, if you have H2 or HSQL on the class path, we'll set up a test database for you that replaces the one that would normally be used. So it's a bit lighter weight. Means you don't need to have MySQL or Postgres or whatever set up on your dev machine necessarily. H2 for today is particularly good because you can run it in kind of Postgres compatibility mode, for example, so it behaves near enough the same as Postgres itself actually does. And we also configure a test entity manager. Don't think we use that in the CFP app, but it just gives you an entity manager that has some extra stuff on it that makes it a bit easier to assert that things have happened in the JPA layer that you would expect to have happened. It's just kind of a little helper utility for your own tests. All right, so what does it look like? How can we improve our app by introducing data JPA test?
So we have two tests actually that are using that. There's a very basic submission test, which is testing the repository layer. To be able to do that with Spring Boot 1.3, what we did was creating a fake class. So basically creating a test class here, which means that only that package will be scanned. So rather than specifying the root CFP application at the root of the COM example CFP package, we start the test with this, which means that the full auto configuration will be applied. We will check everything on the class path like we do when we're starting an app, but we will restrict component scanning, class path scanning to that package. So if we want to change that, it's very easy. We can just write this and get rid of that. And if we do, we will not only we will scan any entities, including entities that are not on this package, and we will only start Hibernate, and like Andy explained, basically only start the bits and pieces that matter. So how come that we actually could scan stuff outside of this package? So data JPA test actually needs a context to bootstrap, right? It needs to have a source to read the initial configuration. The way we do this is we look for a Spring Boot configuration. So we look for a class annotated with Spring Boot configuration in the current package. And if we don't find one, we try with the parent package. If we don't find one, we try with the parent package, etc. until and if we don't find any, we'll give up and throw an exception. CFP application is annotated with Spring Boot application, and actually that one has Spring Boot configuration. So that's why Spring Boot application doesn't have the regular configuration, but the Spring Boot configuration specific annotation, which is nothing but configuration, by the way, so there's really nothing explicit about it. It's just strongly typed. So my context now doesn't need to have any sort of bootstrap context. By default, I'll find one, which means that if you want to customize things, you can also create a Spring Boot configuration in that package, and it won't use the one of the parent package. I can reuse that in further, submission service test. So I can also use the data layer in that package. Let's see first what I used to do in 1.3, sorry. In 1.3, I basically have to scan for entities and repositories, but this time they are not in the current package. So I'm in the submission package now, and my domain classes are in the domain package. So even if I start a fake app in this package, it won't find any entity because there's no entity in that package, and there's no way it would look for the domain package. So I have to basically configure things myself in 1.3 to tell it, okay, these are the entities are in that package, you should look for that. In 1.4, I'm just asking Spring Boot to start in restricted mode for data, data-related test, and I can get rid of all of that. But if I run it, the test will fail because submission service is unknown. We can try that. There's no reason to scan submission service because it's not supposed to. Class path scanning has no reason to include that file. So one way to do it is, like I did for the security config, is just to include an extra class. So tune that mini application context with an extra class that you actually need to use. Okay. Anyway, back with green.
Before we go back to the slides, I realised we missed a bit in the web bit that might be worth doing. We didn't show the HTML driver stuff.
Yeah, we can do that right now.
Sorry, we missed a bit in the web stuff. There's also support for, as well as using mock MVC, there's also some other support for using HTML unit, which we'll show you now.
So I need to add the dependency. So remember, auto-configuration works by detecting stuff on the class path. Now with 1.4, you can do the same thing for tests. And I'm adding the HTML unit driver, and what I'm going to do is I'm going to write the exact same test than this one, but rather than using mock MVC, I'm going to use HTML unit. So let's clone that class. And I'm not going to use mock MVC, but I'm going to use a web client that I can auto-wire, and that's what web MVC test is going to give me. All the assertions are the same, but I'm going to use the form. I'm going to get the HTML form, set some values in that form, extract the the submit button and actually invoke, click on the submit button. So that way, that test is actually testing the fact that the controller returns you the initial form, then you fill in the form, and you submit that form to the server. So the difference, oh, I forgot to remove that, by the way. That's not necessary. So if you look at the mock MVC test and the HTML unit test, they really look alike. And the only difference really is the component that you inject in your test that Spring Boot provides you.
The bit that Stéphane just removed there that he'd forgotten was the before piece to reset the mock. When you're using mock bean, the mock is automatically reset at the end of every test for you. You can configure it. I think there's an attribute on the mock bean annotation that lets you control the reset behavior, I think.
Yes.
Yeah, so you can control the reset mode on the mock, but by default it will get reset after every test, so that when the next test runs, your mock is in kind of a fresh state, ready for you to set new expectations on it for that particular test.
Even less good now.
All right, so that was using data JPA test. We have another chunk of our application, GitHub client. So this, as I described earlier, this is using REST template to make HTTP calls out to GitHub's API. And there's some, I think it's a bit of an unsung hero of Spring Web support. Spring Web has a little library, a little class in it for setting up a mock server that you can wire into a REST template, so that your REST template, rather than actually making HTTP calls, it makes calls to the mock server. And then you can set expectations on that mock server and say, I'm expecting a get at this path, and when I get that request coming in, I'm going to return this response. And you can narrow that down, saying I'm expecting a request with certain headers or all sorts of things. So it lets you basically set up a mock server that will behave in a particular way, and then you can test that your client acts as you expect, given the server's behavior. But that can be a bit of an effort to set up. So we have a REST client test annotation, which applies the same theories as the Web MVC test and Data JPA test, but to something that's using REST template. So again, this hopefully you're all becoming quite familiar now. We switch off auto configuration so we can control exactly what does and doesn't happen. Again, there's some type exclusion filtering going on, so we only include types that are appropriate for testing a REST client. Again, we set up the special cache manager to stop caching getting in the way and messing with your tests. We auto-configure web client, and we auto-configure the mock REST service server. So that's the thing that I was just describing, where you have this mock server, and we can set one up automatically for you, so that then all you need to do is basically set expectations on it and use it, rather than having to write the boilerplate to set one up. So what does that look like?
Okay, let's see. So this is this test here. This is the boilerplate that you have to write. So for that thing to work, the REST template instance needs to be shared between the client and the mock server. Basically, what the mock server is going to do is change the REST template so that you don't actually hit the endpoint that you want to test. And it will replace that by something that's going to check that the right call have been made. So I'm creating a REST template. I need a mock for the counter service. So my GitHub client test is using some counter service. I'm going to mock that. I'm creating a new mock REST service server with the REST template. And then finally, I'm creating my GitHub client myself with the dependencies that it needs. And what's really important is that that REST template is shared between the two. If I look at the class itself, you may have seen that this morning. The GitHub client actually is injected. So the production code is actually using this constructor, because we tune the way the REST template is built. We add an interceptor to make sure that our calls to GitHub are authenticated. In the case of the test, we need to pass the REST template. So we have this protected constructor to make sure that we can pass that in. So that constructor only exists to be able to run tests with that infrastructure.
And tying into the question we had at the end of the first session, because there's two constructors here, you have to use auto-wired on one of them so that the Spring Framework knows which of those constructors should be used for dependency injection.
So let's see first how we can improve that code with another feature that's going to be useful in this case. New in 1.4, we now provide you a REST template builder. So REST template builder will basically share all the customizations that have been found in the context, such as custom HTTP converter, custom interceptor, other customizations that you want to do on your REST template. It will inject you the builder with all that information and allow you to further customize it before creating an instance. So in this case, I'm going to assign the counter service, obviously, and I will use the builder to add an additional interceptor. Here we go.
One thing to note about the builder is that it's immutable. So every method that you call on it doesn't change the state of the instance that you're calling. It actually returns you a brand new builder with the changes applied to it. So we expect it to be used in kind of in a chain series of methods style. So you call a bunch of methods on the builder and then you build the template at the end. Don't fall into the trap of kind of calling, customizing the builder, applying lots of customizations as separate statements, because they won't have the effect that you're expecting. You need to chain everything together and then use the thing that's built at the end.
So in this case, that builder will have all the defaults, all the things that Spring Boot has found in the context, and the minute I'm calling this, I'm basically getting a customized version of it for only that REST template. So if I go back to my test now, I have some problem because it doesn't compile anymore. So let's see what we can do. So one thing we can do, as Andy mentioned, is to use REST client test. Don't need that. And REST client test can, as we've seen for WebMVC test, can take the name of the component that you want to test, and that will automatically add that to the application context. Once you've done that and you're using the REST template builder infrastructure, the auto configuration of the mock REST service server is going to make sure that the REST template are the same. So if you use that infrastructure, all you have to do really is just inject those two components, and you can get rid of all of that, since we know now that we can easily create a mock like this. Let's run the test. And then we can quickly see also the expect JSON. So this is what Andy explained with the mock server. You can expect a request to a certain URL, expect a certain HTTP method, request headers, etc., and then you can say what kind of content you're going to return. In this case, we have like some JSON data that we used to actually mock what GitHub is supposed to send us back.
All right, so that was REST client test, which is the last of the slices that we have. Probably worth. We don't have time to go into the details of it today, but you can also write your own slices, your own whatever test annotation. There's a blog post that Stéphane wrote showing how to do that for
JDBC,
JDBC
template. Yeah.
So we have a data JPA test slice, which is for testing data access via Spring Data JPA. There's a blog post showing, and it may make it into Spring Boot 1.5, I suspect. There's a blog post which shows you how to create one for JDBC-based data access, and you could use that blog post and what it does as a template for creating your own. It kind of walks you through all the steps of the type exclusion filters and all the rest of it, and how you might like to do it for testing a slice that's maybe specific to your application and its architecture. So in addition to testing individual kind of slices of an area of your application's functionality, it's still important to test the application as a whole. Slice testing I don't think to be a complete replacement for a full-blown integration test. It's still important to check that your application kind of works properly from one end to the other. So you still want to have some full-blown integration tests. Maybe not as many as you would have had in the past, but you still want some to make sure that everything's still working when you view it as a whole. So for that, when you want to test the whole thing, we have a Spring Boot test annotation. And this is kind of similar to how Spring Boot 1.3's testing was, in that it creates the whole application context, starts everything up for you. But there's some nice additions that it lets you do, and you can also combine it with some of the slicing stuff that we've just talked about. And Stéphane will show us that now.
So let's take the CFP controller test again and make that an integration test. So I don't want to use a mock anymore. I want really to call the service, and that service called the repository, and make sure that the data is actually in the database. So to do that, I'm going to switch that to Spring Boot test. And again, it's going to do the same thing, looking for a Spring Boot configuration in the current package and looking in parent packages until it finds ones. Which means in this case, it will load the CFP application class. Because I'm running an integration test, there is no need for me to import the security config myself anymore, because like we explained, everything is going to be scanned in this case. So I can remove that. And I need to check that everything went successfully. So you probably will write something more smart than what I'm going to do. But I can inject the repository and check, run some kind of query to make sure that the data is in. So that should be repository, find by speaker email. Very clever, right? This is super clever. I'm so happy to do this. All right. One thing, though, is if you write an integration test, there's no indication that you want to use mock MVC versus something else. So you should trigger that explicitly, and we show that that annotation on the slide. So you should add auto-configure mock MVC to make sure Spring Boot does that for you. And
you can use the various other auto-configure annotations that we showed as part of the slices. You can use, there's various other ones that are quite useful. Auto-configure test database can be handy. This app is using H2, I think, anyway. So auto-configuring the test database for this specific app isn't as quite as interesting. But if you were using, MySQL or Postgres or whatever, but in your test you wanted to use H2, you can still take advantage of the database, the test database auto-configuration in a full-blown integration test by using the auto-configure test database annotation.
Right.
What do you want to actually, you can do?
Oh yeah, I missed something, sorry. Yeah. So the nice thing you can do also about Spring Boot test, I hope that's what you meant, is you can also play with the environment. And you can basically tell it to actually start the servlet container, which is not the case in this case. But if you want to do a test using REST template, for instance, you could say random port. Once you've done that, you can inject a test REST template and simply do your calls, and it will reach automatically to localhost the port that was allocated, so that you don't have to take care of that.
And that under the covers is using the local server port stuff that I talked about that's added to the environment during the startup when the embedded servlet container fires its initialized event. The thing that auto-configures the test REST template hooks into that to figure out what port it is that the container's listening on, so that it will then connect to the right port in your tests.
All right.
All right. We've got 4 minutes or so left. That's everything we had. Thank you very much. I hope you enjoyed it. I hope you found it useful. We'd love to hear your feedback, either in person or voting in the app. We'd particularly love to know what you think worked well, what we could have explained a bit better, whether it was too high level, too low level, basically anything that you can say that's kind of constructive to help us make the presentation better for the future, we would absolutely love to hear. All of the code that Stéphane walked through is available on GitHub. Do you want to?
Yeah, so the first link is really the first part where we build the auto configuration, we change the environment, the application events, and the failure analyzer. All that is the first link. The second thing is, like I said, it's an application that I borrowed from a different talk. So if you go on the master branch, you'll find that CFP sample app, but with many more features like OAuth2 integration and plenty of other nice stuff. And there's a DevOps test branch where all the commits is basically the demos that I've done today.
All right. We've got 3 minutes 30 left. I can see the screens telling me. So does anyone have a quick question? No, I don't think so. All right. Thank you very much, everyone. Enjoy your rest of the time at the conference.